Here's our tips and tricks.
Okay, let me share my screen real quick. Get that going. So, Lab 5 is a bit of a shift in terms of coding, at least for me. I remember when I took the class, it kind of is a bit of a deep dive into probability, which can seem a little intimidating for people, especially if you haven't taken the class, like I hadn't at the time. So I kind of wanted to just go over some major like concepts and ideas that are going to be presented throughout the lab, just so it's not completely foreign to you and that it doesn't look super intimidating. Because I know that can be a huge thing that holds people back. So we'll just get started on that. One of the first things I kind of wanted to go over, it's pretty quick, pretty easy, is the Boolean expressions. All it basically is, it's basically just reading a statement and evaluating it to either be true or false. So if you take it pretty literally, as you can see on the left, it says 5 is equal to 10 divided by 2, which we know to be true, but we can see the expression prints out it also to be true as well. Um, and the same goes for false statements. So we see 6 equals 10 divided by 2, which we obviously know 10 divided by 2 equals 5. So it prints out as false. So it basically just takes two statements or expressions. It can, in this case, we have numerical values and just puts an operator between them and it evaluates whether to be true or false. Um, that's as simple as it gets in terms of Boolean expressions, at least. But we will move on to um, just some more examples. So you can see I have a little picture here of all the potential operators. I'm sure you've seen them before, our equal sign, our greater than, our less than, our not equal to. In this case, on the computer, they look a little different um, because obviously we can't type them exactly how we write them when we're, taking a math class. So as you can see, we have on the left, 4 plus 7 is not equal to 11. So that exclamation mark equal is not equal to, which I know I kind of got mixed up a little bit at first because I was like, wait, what is that? Like, that's not usually you'll see a cross on the equal sign. So it's definitely something to get used to. But yeah, you can see that it's considered false because 4 plus 7 is equal to 11. So it printed out false beneath it. And then same thing goes for the one underneath. We have 17 is greater than or equal to 14, which we know to be true, and it gets confirmed and is printed out as true as well. So, this is always something you can come back to reference if you ever forget what an operator means. And I believe this graph here, this little chart, this table is in Lab 5 as well, so you can see that there, just as a reference if need be. But we will move on because that's really it for that. One of the bigger things you'll definitely want to take note on is conditional statements. Um, so basically, it's a multi-line statement. It allows Python to choose between different lines of alternatives based on the truth value of an expression. So it's easier to show you with an example. So here I made my own conditional statement. Obviously, we have our def, our def at the beginning to create a new function, a new statement. And then we have our name, which is sign, x our placeholder, colon. And then here we have to start with our if statement. So if x is greater than 0, we return positive. And we actually see an example of that on the right. So like you take sign and you put 9 in parentheses and it spits back a positive. And then we do the same thing with a negative, with negative 83, and same thing with sign 0, which prints back 0. But obviously you see instead of if, it says elif. So you start with if for the first statement, and then as you create more if statements, you use elif instead. But it's all the same principle. You always want to make sure you put a colon at the end of them, otherwise the computer's gonna yell at you basically. Um, but there will be a question regarding, I think, types of pizza in Lab 5 that you'll see. Um, so make sure you take note of this type of function. So random choice also going to be used for the pizza, um, returns a randomly selected element from a specified sequence. So you can see I created an array, a list of names of animals, and used my np.random.choice on that array, and it basically printed snake out of the list. It randomly picked an animal from that list, and then the second time I ran it, it printed out beaver. So it's pretty self-explanatory, obviously. You can see it just randomly picks from a list. It can pick from numbers as well. You can use it in a lot of different ways to run, like sort of like simulations, that sort of thing, because we'll definitely get more use out of it later in the lab as you'll go through it. But this is just a very simple way of using it. So I wanted to do an example combining a conditional statement and random choice. So this is a very simple example. So basically, I just created a new array with the numbers 1, 2, 3, 4 spelled phonetically, and then created my conditional statements. And if you see at the bottom here, it printed out 2 when we plugged in our np.random.choice numbers list into the number function, and we got 2 from it. So kind of going backwards, we can see how that happened. So we asked np.randomChoice to pick a random string from our list, either 1, 2, 3, or 4. It picked 2, TWO. And then in our conditional statement, if the value equals TWO2, it returns the number 2, which it did. It could have randomly picked 3 and spit back the number 3. Could have done it with 4, could have done it with 1. It's just an example to show you how it kind of, you could apply both into one, like line, like a few lines of code. Like you could put everything together basically. So that's just an example of that. But one of the big things I kind of wanted to go over was probability, because that kind of gets introduced in this lab, and it's a bit intimidating. There's a lot to go over, so I kind of just wanted to do like a brief overview. In the simplest of terms, probability is just a way of measuring how likely something is to happen. So from 0 to 1, 1 meaning 100% chance it's going to happen. We're certain it's going to happen. 0 meaning never. And we have our probability formula in the top right. So if you haven't seen this before, the probability of the event occurring, so say we're looking at, so whatever event it is, the number of ways that event can occur divided by the total number of outcomes, including the ways that event can occur. So I'll show you an example and it'll make more sense, because me talking at you might not be the easiest way to understand. But there are some other rules I just wanted to give a quick mention. So if you wanted to find when an event doesn't happen, you're basically just taking your 1.0, your 100%, minus the probability that the event happens. That's what that P stands for, probability. So 1 minus probability that an event does happen will equal the probability that an event doesn't happen. And then also there's the multiplication rule. So say 2 separate events were to occur back to back. The way you would find the chance of both of those occurring is to just multiply their probabilities. And I'll show an example of that as well. So let's look at them now. So the simplest example I can give is just rolling a dice. There's 6 possible outcomes. So 1 through 6, right? And if we were to look at, oh, like, what if I rolled a 5 out of, what if I wanted to roll a 5, what would the probability be? Well, it'd be 1 out of 6, because as you can see with our probability formula, we want a 5. Well, there's only one side that has 5. So it'd be 1 divided by 6, because there's 6 sides. So it'd be a 1/6 chance of that occurring, or 0.16 or 16%. Say if you wanted to roll below a 3, in this case, that would include 1 and 2. So there'd be 2 different ways for an event to occur divided by the 6 total outcomes instead. So 2 divided by 6. which is 1/3 or 33% or 0.33. All right. And then another popular example that I definitely saw in my stat and probability class was the marbles in a bag. They're different colored marbles. Basically, you can see there's 10 here, and we're looking at the chance of picking a blue marble. So the possibility of picking a marble, there's two marbles total. There's two blue marbles, excuse me, like divided by 10 total marbles. So as long as I'm picking one of those two blues, we're good. So 2 divided by 10, 1/5, 0.2. Same principle. Chances of picking a blue marble after we picked out the first one. Well, if we picked that blue marble out first, obviously we're going to have one less total marble, but also one less blue marble. So you would subtract one from both the 2 blue and the 10 total for it to be 1 blue divided by 9 total instead. So it'd be 1/9 or 0.1111%. And then just another example down here, this is the multiplication rule. So say you have a 0.7 or 70% chance of passing an exam. Well, you want to pass two exams back to back, you just multiply zero point 0.7 by zero point 0.7 and you get 49%. And it seems a little intimidating at first, but the more practice you do, the easier it gets. So that is my little overview of probability. There's much more to talk about, but that's for probability class.
Wow, that was super clear. Wow.
Thank
Great.
you. Thank you.
Yeah.
Yeah, I'm sure my stuttering didn't help, but that's okay.
Oh, right.
I just wanted to talk about p-test as well, because this I found the most confusing when I took this class. Um, I would say the very first thing you want to know is hypothesis versus null hypothesis. And I'm sure we've all heard of a hypothesis before. You kind of make a statement about like a characteristic of a population based on a set of observations, a set of data, whatever you want it to be. But there's also the null hypothesis, which is basically when there is no significant difference between a population. So any observed difference within a population is basically just due to like chance, like 50-50 chance. So there's no exact cause, if that makes sense. Um, and basically within the p-test is the p-value, and that specifically is what determines whether we would reject the null hypothesis or not. It doesn't necessarily confirm if a hypothesis is true, but we can definitely confirm whether or not something is due to random chance or not. So a low p-value, and typically you'll see either 0.05 or 0.01, um, if you, depending on, how specific you want to be, um, then that would suggest that the null hypothesis is not true, meaning that this event occurred and it's not due to random chance. It's not due to like a 50 out of 50 chance of happening. It doesn't necessarily confirm that the hypothesis you created is true. At that point, you would have to probably do more testing to see if it was true, but it does confirm that there is a specific cause at the very least. If a p-value was higher than 0.05, 0.01, whatever you decide to use, it means that the null hypothesis cannot be rejected. So that means, there may be a random chance that this event is occurring and it's not due to any specific cause. And I think that's something that people have a hard time wrapping their heads around. And, if you ever need more clarification, you can always like ask or, read the textbook. I find that very helpful when I'm trying to look up. Honestly, I've read it for this slide as well, like for these slides when I was trying to explain something. Um, but if you're overwhelmed in any way, shape, or form, don't hesitate to ask questions or even, look on YouTube, look at our videos. Like there's plenty of source resources for you to reference. And the very last thing I just wanted to do I've kind of compiled a list of reminders based on like attending the classes and seeing what people are doing. Make sure you are rerunning all your cells every time you go back into a notebook, because sometimes a check won't run or something needs to be defined again. So your best bet is just to rerun everything every time you tab back into a Jupyter notebook. Usually that solves a lot of people's questions. Um, Obviously, read the questions. Believe it or not, there are people who just kind of skim right through them and they're like, I don't know what to do. And then I say, well, read the question. What does it say? And they're like, oh, yeah. And then they do it. So it does help, believe it or not. um, Obviously, ask questions. That's what we're here for. Um, Check your spelling. A lot of errors also consist of spelling errors. So if one letter's off, the code won't run, basically. If your variable isn't exactly the same as you defined it, it won't run. It won't know what you're talking about. Um, and also, one that I think is underrated that I used to do a lot is feel free to look back at your old labs. If you forget how to do something, say you wanted to use like the .where command, you can look at your old labs and reference them to use them now because they're going to be useful from here on out. If you forget something small, it's easy enough to just go back and look at them. Um, and obviously, read the textbook, like I said earlier, if you want clarification as well. But that is all I really have. So if there's any questions, now would be the time. But yeah, thank you.